Hey guys, I'm Sandhya. Today I'm back with another video. In this video, I'll explain Leetcode problem 268, missing number. Before heading on, please hit on the like button, share and subscribe to my channel. Okay, let's read the problem statement now. Given an array nums containing n distinct numbers in the range 0 to n, return the only number in the range that is missing from the array. So in this problem, what we need to do is we are given an array nums in which there are numbers from 0 to n with one number missing. So we need to find that missing number. Okay. So this problem could be solved using O of n log n complexity, which uses merge sort and all. First we can sort the entire array and then we can find the missing number. But instead, in this video, I'll explain how to solve this problem in linear time complexity. Okay, so first thing, you need to know what an XOR function does. An XOR function generally, according to truth table, it returns true for two same digits and false for two same digits and true for two different digits. So what I mean by that is, when we do 0 XOR 0, we get the result as 0, and 1 XOR 1, we get it as also 0. But just in case we do 1 XOR 0 or 0 XOR 1, we get the result as 1. Okay, so from this what we understand is that an XOR function, when it XORs two similar numbers or two same numbers, it returns false. But just in case if there are two different numbers, it returns true. We are going to apply the same thing in our problem. First, what we are going to do is we will XOR all the elements in the nums array. Okay, so let's take example 1. In example 1, we have 3, 0 and 1. We need to XOR all these numbers, 3 XOR 0 XOR 1. Okay, and we'll take another variable in which we will XOR all the elements from 0 to n. This even includes the missing number. So we will make some loop or something and then we will XOR all the elements from 0 to n. Okay, so let's do this. 0, 1, 2 and 3. Since there are 3 elements, length of nums is 3, we'll do it from 0 to 3. And these two variables, we are going to XOR them together. Okay, now when we XOR, okay, I'll make this a little more clear. Okay, when we XOR these two numbers, these two variables, first variable contains the XOR of all elements in the nums array, actual elements present, and the second variable should contain XOR of all the elements from 0 to n. When we XOR these two numbers, the same numbers as I said previously would result in 0. Okay, so 3 XOR 3, here we have 3 and in this also we have 3. So these 3 XOR 3 would result in 0. Similarly, 0 XOR 0 would result in 0 and 1 XOR 1 would result in 0. When all these are 0, we would get the final thing as 0 XOR 2. When any number is XORed with 0, it results in the same number. Okay, so the result should be 2. Now in this we got the missing number as 2. So this is the mechanism and this is the way we are going to implement our solution. Let's start coding. Okay. We'll take two variables as I said now, int XOR 1 and XOR 2. We will initialize them to be 0. XOR 1 is equal to 0 and XOR 2 is equal to 0. Okay. Now we'll XOR all the elements present in the nums array using a for loop. We'll iterate through a for loop. We'll use the int variable as I equals to 0 pointer. um, till I less than equals to nums dot size. We are going to XOR all the numbers. So what we do is we just take one number at a time and XOR that to the entire result. Okay, nums of I. So each time a nums of I is XORed, it would be placed inside the XOR one variable. Similarly, we would do the same thing, but for entire I is equal to 0 to n, which even includes the missing number. See, I applied a I less than equal to nums dot size. Okay. Now the variable we would take is XOR 2, and we would do the same thing as we did previously for XORing the nums of I elements. But instead of XORing nums of I, here we would XOR I value. Okay, we need to XOR 0, 1, 2, 3, etc. So we need to take I. But previously we did nums of I because we need to XOR all the elements from nums array. Okay. Now we can return XOR 1 XORed with XOR 2, which means the first result XORed with the second result. Okay. Let's see if the code works. It should work. Okay, this is faster than 72.77, so it's better than the previous n log n complexity. Okay, so this way we can solve this problem in just linear complexity, time complexity. So if you still have not yet subscribed to my channel, please do subscribe it, and thank you.